Hey Science Explorer, have you ever wondered making a lemon battery or turning a lava lamp with simple kitchen ingredients? Science is not just a fact. Science is pure magic happening all around us. From the air we breathe or the gadget we use, science is in everything. Today, we are diving into 3 mind-blowing experiments that will make you see the world differently. And the best part is you can try them yourself. Now we are going to create a lava lamp using simple household ingredients. This experiment demonstrates a fascinating chemical reaction between baking powder and vinegar, which produces carbon dioxide gas bubbles. The movement of these bubbles, combined with difference in density and solubility, creates the mesmerizing lava lamp effect. First, take a small amount of baking powder and place it in a clear glass. Then, pour in cooking oil. You will notice that the oil sits above the baking powder because it is less dense. Next, in a separate glass, mix vinegar with few drops of food coloring to make it visually vibrant. Now, carefully add this colored vinegar into the glass containing baking powder and oil. Immediately, the vinegar reacts with the baking powder, triggering a chemical reaction that produces carbon dioxide gas bubbles. These bubbles attach to the vinegar droplets, reducing their density and causing them to rise through the oil, creating a beautiful lava lamp effect. Let's start with lemon battery. Here, we will transfer a simple lemon into an electricity generator. Are you ready for some citrus-powered magic? A lemon battery works on the principle of electrochemistry, where two different metals, nails and copper plate, act as electrodes, and the citric acid in the lemon serve as electrolyte. Take the lemon, put the nail in the one side of the lemon and place copper rod on the other end. Some interesting chemical reaction will take place inside the lemon. Oxidation at the zinc electrode, the nail reacts with the acid in the lemon juice, losing the electrons and forming zinc ions. This reaction makes zinc the negative electrodes as it releases electrons. At the cathode reduction takes place here, the hydrogen ions from the lemon juice gained electrons. Copper itself does not participate chemically, rather it attracts iron electron more strongly than zinc through the external circuit. So, loose electrons from zinc will move towards the copper when the electrodes are connected by wires. If we attach a LED wiring with it, then electricity will generate because this creates a potential difference between the nail and the copper plate's electrodes. And finally, we are going to observe an intriguing phenomenon known as the Tyndall effect, the scattering of light by particles in a mixture. For this experiment, we have prepared 3 different solutions: salt water solution, milk solution and flour solution. Each of these solutions will be testing by passing light from a source through them, revealing some fascinating results. Let's explore the science behind what happens. When we shine the light through the saltwater solution, we notice that no light is scattered. This is because salt dissolves completely in water, breaking down into tiny ions that are too small to disrupt the path of light. When we pass the light through the milk solution, we see significant scattering. This happens because milk contains large particles such as fats and proteins, which bounce the light in different directions. Lastly, in third solution, water is dissolved with flour and passes the light. This solution scatters light but in less amount because its particles are larger, less uniform and tend to settle, while milk contains smaller, stable particles that are ideal for scattering light strongly. The Tyndall effects help us to distinguish between true solution and colloidal mixture. It is also the reason why we see the beam of sunlight filtering through fog, dust or smoke, just like how light scatters in our experiment. This simple demonstration proves a fascinating insight, particle size, light behavior, and the science of solution. That's enough for today. Let me know in the comment below which of these experiments you would like to try at home.